Hi, welcome back to DataFrame YouTube channel. This is another interesting series of videos that will focus on data frames. We want to learn how to begin to work with data frames as data analyst. Before we dive deeper into it, let's see the learning objectives. By the end of this series of videos, we'll have through the next few videos, you should be able to sort and filter pandas data frames, create and delete columns in pandas data frames, and apply custom transformations to pandas data frames. This series of videos will be structured in this order. We use the football players data sets that we started using from the previous series of videos on introduction to NumPy and pandas. We will also manipulate pandas data frames through sorting and filtering. We'll alter pandas data frames by creating and deleting columns, and finally we'll transform pandas data frames using custom functions. Let's begin as we look at the introduction to this collection of videos. When a data set only has a few data points, it's very easy to manually apply operations to the entire data set. However, a good data sets are very rarely this small. Therefore, when working with such massive data sets, pandas library in Python will allow us to use some form of vectorized operations, that is, operations across multiple data points simultaneously, which makes it much easier to work with such large data sets. In this series of videos, we will look at how to manipulate data within data frames. Let's begin by importing the pandas data frame as PD. Okay, so the first cell, I will be importing pandas data frame as PD. Yes, we have the package imported, and here let's load in our data sets. Remember, I said if you are importing a data set from your computer, local PC, then the data set has to be stored in the same location as where this Jupyter notebook is stored. The Jupyter notebook that runs this code, they have to be in the same location. This data set can also be found in my GitHub repository, alright, through this link, but I'm not using it right now because my network is not so great, and I'm having some errors, network error, like the URL is not going through. So that is the reason why I want to stick to the one that I have in my local PC. So now, once I load the data sets, I would like to see the first 5 rows, and there we go. We have these data sets already imported as a pandas data frame. Okay, now let's learn how to sort our data sets. Sorting is one of the basic functions that you will have to perform as a data analyst when working with data sets, and you can sort by any column of your choice. In our first example, I'll be sorting by the age column, and without passing any other parameter into the sort values method or function, by default it will sort the ages from the youngest to the oldest. And because I have added .head, this will return the first 5 values or records. So once we run this cell, you have the youngest player, which is 18 years old, and the oldest in the first 5 view to be 20. Without adding the .head, this will give you a list of all the players, and with the record sorted according to their ages. So you can see it's clearly shown that this is already sorted, and the method or the function to sort is called sort_values. Then you give it giving some parameters. What if our interest is to sort this in ascending order, or in descending order, I mean from the oldest to the least? We have to add an additional parameter to say, or additional attributes to say ascending equals false. Note that your false begins with a capital letter F. The order syntax remains the same. df.sort underscore values in the bracket sort by, so you have to add the by parameter, the by keyword by age, okay, and then you choose ascending equals false to let this be sorted in descending order. So here we have the oldest from oldest to the youngest in that order. So this is me sorting only by the age. We can sort by columns, you can sort by multiple columns, and so on. Just give a list of the columns you want to sort with by here, and then the sorting would just go out, be presented exactly how you would like to see it. I'd like you to put that into practice on your own, practicalize it to see what output you get. Alright, so that is how to sort using sort data sets that is stored in pandas. Let's talk about filtering. Filtering is a way of getting a subset of your data set by adding some conditions. So here, my first interest is to view all the players that are older than 30, and here is how I'm going to slice that. I want to use this method of slicing. So first of all, I'll split this code into two different parts, or let's first copy the code that's inside that square bracket, paste it here. So when you say dfh, okay, I comment this line first. When I do dfh, it means I'm just getting out the column, the age column gives me just these numbers, the age column. But when I say df age greater than 30, this gives me true or false boolean values. Can you see here? Here it shows false for Lionel Messi, because I think Lionel's age here is 24 as recorded in this data set. Cristiano Ronaldo, we have true because his age is more than 30 as recorded in this data set. True, false, false, true. So once you put your comparison operator, it returns a boolean value. Okay, now with this boolean value in this, trying to want to use that to filter out the record. It means wherever, so I'm saying, hey Python, please give me the rows where this particular input is true. So every other place it is false, don't return the rows. That is the exact message I'm passing, or instruction I'm giving Python right here. And once I run this cell, it gives me just those that are greater than 30. As you can see, the ages here are 37, 32, 38, and so on. It's just the players who are older than 30 that are returned here. So I've filtered by the age. Okay, and when we go further, you can also filter by multiple conditions, where the ampersand is used to test two conditions. Say, give me the records where this part is true and this part is also true. It is only where both parts are true, that is when those are the values or the rows or records that Python will return. But when I use the pipe or vertical line, this will return the records where this is either true or this is true. So if any one of them is true, then the records will be returned in the case of pipe or vertical line. So here we want to filter players that are older than 30 and overall rating is 90. So we want to get the players who are older than 30 and whose overall rating is more than 90. Okay, and watch how this syntax is written. In a curved bracket, I put in my first condition. In the second bracket, I put in my second condition, and then they are all wrapped in a square bracket. And once we run this cell, it gives us the expected output. For us to easily see our output and expect if this is actually satisfied or not, let's just return the age and the overall columns only, leaving others alone. And how do you do that? You give a list of the columns of interest. So I want to get that by this list of columns of interest, the age column. So I just need to see the age column, comma, I also want to see the overall column. Okay, and once you do that, you can see with this I have sliced out other columns, leaving just the age and the overall column. So these are the records that satisfy these two conditions. Here you see you have age 39 and overall 90, age 38 overall 92, age 39 overall 93, and so on. But if I say those who are older than 30 and whose overall is, let me just give a ridiculous small number, say 20, and I doubt if we can find any of such record, but let's just try this and see what happens. Great, so nothing. You see, there is no player who is older than 30 and has an overall less than 20. Now, but if we put a pipeline here, where I expect to see records, because for this pipeline it's like the operator representing or, the ampersand is equivalent to and. The pipeline should return something because we can find players who are older than 30 even if we don't have players whose overall is less than 20. Let's run this, and as you can see, we have some outputs, quite a number of them. By this, you would have seen already that it is only those who are older than 30, the condition that is being satisfied, because when you look through the overall column, you find no overall rating that is less than 20. All are greater than 50. Do you understand? So that is how to use this pipe or vertical line for or, and then the ampersand for and. Alright, so let's take this out. That was added just for clarity. Okay, so we are working with greater than 90. That is the correct code. Great, so that's how to work with filter using multiple conditions. Alright, so I think this is a good place to stop this first part of the video. We'll continue in the next part where we'll learn how to create columns and add them to Pandas DataFrame. I hope you found this video educating and interesting. Please remember to like the videos, share, and most importantly, if you've not yet subscribed to our YouTube channel, please do so. Go ahead and hit the subscribe button just for you to have notifications when new interesting contents of this kind are posted. Thank you guys, and see you again in the next one. Goodbye.